Depreciation. Items such as cars or electronic goods become less valuable over time. This is called depreciation. When the value of an object decreases to a point, it is referred to as scrap value. There are two types of depreciation that can be modeled by linear decay. One of them is the flat rate depreciation, the other is the unit cost depreciation. Flat rate depreciation is how much something is worth over time. So my V0 here will be whatever my initial value of that item is. So this often is things like where we refer to things such as cars, it could be houses, it could be laptops, that sort of thing. D is I suppose in a way, a simple interest fee. And I'm just going to put inverted commas. Depreciation rate. Recurrence relation will, instead of plus D, we're taking away the amount each time. Now, unit cost works slightly differently. It still has an initial value as V0, but this time the D amount is the cost per use. So when you see unit cost here, so unit cost, it's cost per use. So this is usually a dollar amount. So for example, you might have something along the lines of a printer depreciates by 15 cents for every use or something along those lines, or for every 500 copies printed. But again, the recurrence relation is still the same sort of format, and minus D. So the difference between the two is as soon as you see flat rate, that means we have to calculate using the simple interest formula. If you see unit cost, that is an actual dollar amount. Example 8C.3. A new car was purchased for $36,000 in 2017. The car depreciates by 10% of its purchase price each year. Model the depreciation of the car as a recurrence relation. So my V0 is going to be $36,000. The rate, what did it say the rate was? 10% each year. We don't want to set this up as a monthly thing, so we can leave that 10% as it is. The D amount is equal to 10 over 100 times by 36,000, which is equal to 3,600. And so my recurrence relation, we start by writing the initial value, so 36,000. Put a little comma there. Vn plus 1 is equal to Vn minus 3,600. And there is our recurrence relation. B, what is the value of the car in 2019? In 2019, that is 2 years later. So this would be in V2. Now you could either do one of two things. You could set it up as a recurrence relation in your CAS, or you could just take away 3,600 from that initial 36,000. So 36,000, we minus 3,600, so that's 2018, and then we minus 3,600 again, and that gets me 28,800. How many years until the value of the car is 0? So we can keep subtracting, but you know me, I'd rather work faster or work smarter, not harder. And we're just going to keep clicking down until we get to 0. So here we go, 10 at V10, it is equal to 0. So that means 10 years later. So how many years until the value of the car is 0? So 10 more years, this is implying. Now, sometimes there is a trap. And the trap is that in the exam, they might say, in which year? Now, if they say in which year, that means you have to actually use the year in question. So for example, for our one, it would be in the year 2027. So that's what they mean by in which year. So you'd have to give the actual date. If they say how many years, you'll write 10 years. If they say in which year, then you have to actually take the original year and add 10. Example 8C.4. A gardener purchased a whipper snipper for $360. The whipper snipper depreciates in value by $5 each time it is used. As soon as you see that, that is a unit cost depreciation. Model the depreciation of the whipper snipper as a recurrence relation. Well, I know my V0 is going to be the original price, which is $360. I know my D value is equal to 5. So therefore, the recurrence relation will look something like this. All right, V0, 360. You always need to put that initial value in there. And Vn plus 1 is equal to Vn take away 5. As a further reminder, even though we're depreciating, please do not say n minus 1. That's what that suggests, is that you're referring to the value that comes beforehand, not the value next. So keep it always as Vn plus 1. What is the value of the whipper snipper after it's been used 10 times? Well, essentially what we just need to do, if I know that each time it's being used it's going down by $5, so then I just need to go and do 10 times $5, which is 50. And so 360 take away 50 is equal to 310. Or again, I could use my sequence to be able to identify that. So if I went on to sequences and I took away 5, we started at 360. And then I did after 5 uses. So after 10 uses, sorry. There you go. So we're at 310. How many times can the whipper snipper be used before its value is less than 300? So I would say that we're very close. It's currently at 10 uses. At 10 times, it's at 310. If I minus another 5, that's 305. If I minus another 5, it's at 300. So in other words, 12 uses. But again, I can just look here. I can see at the 12th use, it's at 300. So 12 uses is the answer I am looking for.